This is an introduction to arithmetic sequences. So we have our first sequence here, so we're going to look at it, and we want to be able to identify how does it grow or how does it change from one term to the next term. So first off, this is our first term. Okay, and I can see that to go from -3 to -2, I'm growing by 2. So from -1 to +1, also growing by 2. So I can kind of continue with this +2, and I would be able to get the, the subsequent terms. Now, you can start with a table if you want to, and so once again, it's a little bit different. We've seen, X and Y before, and this is very similar, so there's a lot of similarities between these. This is just the term number, and this is the value of the term. Okay, so for example, we started here with the first term, 1, and the value was -3. The second term is -1, the third term 1, the fourth term 3. So pretty similar to X and Y. Now when we graph it, there's a little bit of a difference here. So I would do, 1, the first term is -3, the second term is -1, the third term is 1. And you can see that I didn't connect them. This type of graph, we call this a discrete graph because it's like term 1, term 2, term 3. There's no term 1.5. So the points are not connected. It's not a continuous graph like a lot of the ones you've already done before. So this is an important kind of concept to get. Now, often when you're graphing, but you can see that it is linear, and you can also see that it's a function. So once again, if you did the vertical line test, it passes that. So let's look, because we often like to know what happens, what's the y-intercept. So, the y-intercept is once again when x is 0, but in this case, being that we're using the notation n and t of n, we're looking for, what happens here. So we're looking for this point before. And so I can go backwards. Instead of adding 2, I'm going to subtract 2. So if I subtracted -3 minus 2, I'd get -5. So same thing. If I subtracted 2, and then that makes sense too, because you can see here 0, -5, and I can see that this looks like a line, but once again, don't connect it for a sequence. Now, what are these different parts? How do they help us? So first off, we want to identify the type of graph. This is called an arithmetic sequence. And arithmetic is we're like adding it. So we're adding to get from one term to the next. And the explicit equation, if you look at this, once again, it looks like a line. So if we were to write, sorry, it's getting a little bit full here, y equals mx plus b, to write a line, then we can kind of use this as a launching point for this graph that looks like a line. Except that instead of y, we're using t of n, and instead of x, we're going to be using an n. And so we need to kind of figure out what are those other, what is that m and what is that b? Well, we have already figured out the b. That's right here. That was our 0 term. And the m is our growth. That's how we change from one place to the other, the +2. So our equation for the explicit equation is t of n equals, our growth is 2, n, and our y-intercept is plus -5, or we can just go -5. So this is our explicit equation for an arithmetic sequence. Looks just like y equals mx plus b, but with just a little bit of a twist. Now recursive means how do you use one term to help you find the next term? So how do you find one term to find the next term? There are 2 pieces that you need to know. The first is, how do you just go from one term to the x? one term to the next. So to get the next term, okay, t of n plus 1, this is getting really crazy full here. I'll cover this up a little bit here. To get from one term to the next, t of n plus 1, that's the next term, equals my, like, one term. I'm just going to pick one term. And how did it go from one term to the next? I just added 2. How do I go from this term to the next? I just add 2. So this is the recursive equation. However, there are many sequences where you can just add 2. So for example, let's see if I said 4, 6, 8. This is also, to get from one term to the next, is plus 2. So this is not enough information. In order to kind of stick this line on a graph, you need to give me one more piece of information, and that is like a starting point. So I just need to give you one point. Usually we'll just start with the term 1 and give that value. And what that's the equivalent of is saying, hey, here's a starting point, so I've got a line, and then I'm fixing it. Otherwise, I have an infinite number of parallel lines. Like this would be parallel to this, but this gives it that starting point. So when you do a recursive equation, you need the equation, and that's the critical piece that you also need. One of the points. Okay? Now, another piece that you might be asked is, let's fold this up a little bit because it's getting a little funky there. Is it possible for this equation, t of n, to equal 104? So, can t of n equal 104? Well, I'm going to use my equation. Oopsie, where's my equation? Right there. T of n minus 5. Oopsie, sorry. T of n equals, 2n minus 5. And can this equal to 104? So I'm going to just solve this. Add 5, add 5. So 2n equals 109. Divide by 2, divide by 2. Now, if this was, y equals mx plus b, you would be able to solve this and get a number. However, if I do this, I get, 50 something and like a fraction. Okay, so this here is not going to work. And the reason why it doesn't work is because this does not go on a whole time. You get a fractional number. And as a result, okay, so you would get n equals 54.5. Well, this is not a term. Once again, we have term 1, term 2, term 3, term 4. This is not a term. Hence, this value cannot be part of the sequence. Okay, so that's another kind of important piece to get. Okay, well, we're going to pick up in the next video on how to do geometric sequences. So once again, this is arithmetic sequences. Arithmetic sequences are when you add to get from one term to the other. Once again, the explicit equation is very similar to the y equals mx plus b because when you graph it, it's a line. Once again, make sure it's discrete. In order to write the equation, for the explicit, you need to find the term 0 because that is going to give you your equivalent of your y-intercept. And the amount that it changes from point to point, that is your growth factor or the equivalent of like your slope here. So good luck with that, and then check out the video on how to do geometric sequence.